Subject on merging Excel files. Merging Excel files is a kind of issue we often encounter in our daily work. For example, we often need to merge rows of Excel tables vertically or merge columns horizontally. For simplicity, we will refer to these two operations as vertical merge and horizontal merge respectively in this subject. Vertical merge will increase the number of rows and make the merged table longer, while horizontal merge will increase the number of columns and make the merged table wider. In addition, we will also encounter duplicate data when merging and need to perform the duplication operation. For example, both files to be merged on the left contain the data of Lily and Cindy. It is required to keep only one duplicate data after merging. We may also need to aggregate certain values when merging. Merging Excel files also involves the conversion of different formats of tables, such as converting card-style tables to row-based table. All of the above issues are quite troublesome to deal with in Excel. When there are a lot of files, copy and paste is even more inadvisable. To help improve work efficiency, this lecture provides esProc solutions for some common requirements encountered when merging Excel files. We divide the requirements into 5 categories, and each category is further divided into several subcategories, which basically cover most common merge issues. Let's start with vertical merge. Vertical merge involves 4 subcategories, and we will explain them one by one from simple to complex. 1. Merge files with the same name and number of columns. Merging files with the same name of columns is also called same structure merge, which is the simplest and most common way of merging. Simply put, it is to merge several files with the same name, number, and order of columns vertically. For example, there are 2 Excel files with exactly the same name of columns, and the merged table is like this. This requirement is to simply concatenate the data in the tables together. In esProc, we can directly use the set operator vertical bar to perform this calculation. The code is very simple. Read the files as table sequence and perform concatenation calculation on A1 and A2. If there are 3 files to be merged, it will be A1 vertical bar A2 vertical bar A3, and so on. This writing method is direct, clear, and easy to understand, and suitable for merging not too many files. But when there are many files to be merged, this method would be a bit troublesome. When there are many files to be merged, another writing method can be adopted. First, use the directory ep function to list the paths of all XLSX files in the directory. Here it means listing all file names with .xlsx extension in the orders folder. Then loop through each file and merge them using conjunction function. The merging effect is the same as A1 vertical bar A2 vertical bar A3 and so on. This method doesn't need to write file names one by one and then read them in, nor does it need to merge them one by one. It just needs to put all the files to be merged in the same path. The code written in this way is more universal. 2. Different name and number of columns. Keep all columns. In addition to merging files with the same column names, there are also situations where files with different column names are merged. For example, there are 2 Excel files. The first file contains columns name, unit price, stock, and maximum stock, and the second file contains columns name, stock, minimum stock, and unit price. The 2 files have some common and some different column names, and their columns are in different order. Now we need to merge these 2 files and keep all columns. A1 and A2 read the 2 files respectively as a table sequence. A3 creates a new table sequence and uses the operator ampersand to calculate the union of column names. Duplicate column names are displayed only once. Then insert the data of the 2 tables into the new table according to the corresponding field names. If a field value does not exist, it will be displayed as empty. For example, the minimum stock value in the data from A1 is empty, and the maximum stock value in the data from A2 is empty. Different name and number of columns. Keep only duplicate columns. We still use the above 2 files as example. Now it is required to keep only the duplicate columns after merging. That is, only the columns name, unit price, and stock that are common to both tables are kept. The same method can be used to merge, except that the union operator in A3 needs to be changed to intersection operator. The red symbol indicates the calculation of intersection, which means it will calculate the field names that are common to both tables. The remaining code remains unchanged. Different name and number of columns, keep only columns of the first file. We continue to use these two files. It is required to take the first file as a reference and only keep the columns of the first file, that is, the column names of the merged file are the same as those of the first file. Here, it does not need to perform set operations on column names. Just insert the data of A2 into A1. The meaning of insert at F is to insert the data of A2 into A1, only inserting the field values that have the same field name as A1. Be sure not to omit the at F option. 3. Convert file names to column values, unfixed number of files. Sometimes we may encounter situations where we are required to indicate which file the data in the merged file comes from. In other words, we need to add a column in the file to indicate the data source. Use the directory at P function to list the path of all XLSX files in a directory. File name at N means getting the names of Excel files in A1, such as apple, bread. The derive function means adding a derived variable, commodity, to each table opened by the T function, with the value of the derived variable being the name of each Excel file. The conjunction function represents merge, which means merging the tables after adding the derived variable commodity to each table. That is to say, while merging, a column is added to each file, and the column value is the name of each file. 4. Merge multi-sheet Excel files. There are multiple Excel files. The number and name of sheets in every file are the same, and the number and name of columns in sheets with the same name are the same as well. On the left side of the figure are 4 sheets in the first file. Each sheet contains a batch of data. Now we need to combine data in every file into a single file, where data in sheets with the same name are stored in a sheet where only the column headers in the first file's sheet are retained. On the right side of the figure is the merged data, which still contains 4 sheets and is the combination of data of sheets with the same name. For example, the data in the red boxes in sheet 1 come from sheet 1 of different files. Let's see how to code. A1. Define variable dir to store the folder where the target Excel file will locate. A2. List names of all XLSX files in folder dir. A3. Loop through each file in A2. B3. Open the current file in A3 as an Excel object. B4 to D4. If the current file within loop is the first file, store the currently opened Excel object to C2 and go on to the next file. B5. Loop through each sheet in C2. C5. Import the data of the current sheet name from B3's Excel object. At T option enables reading the first row as column headers. C6. Append data read in C5 to the current sheet in C2. At A option enables data appending. A7. Write the combined C2 to output.xlsx. Section 2. Horizontal merge. Horizontal merge generally makes the merged table wider. Similarly, it also involves several common situations, and we will also explain them one by one from simple to complex. 1. Same name and number of rows. We usually need to merge Excel files with the same number and name of rows horizontally. For example, the fruits file contains price information of fruits, and the fruit stock file contains stock and maximum stock information of fruits. Now we need to merge the price and stock information into one table. In these two sets of data, the name and number of rows are the same, meaning that the names and order of the fruits are the same. In other words, we just need to concatenate the stock and maximum stock columns of the second table into the first table. With this logic, it is easy to code. First, use the new function to create a new table sequence and then extract the required field values from the same positions in the two tables. The returned result is shown in the figure. 2. Different name and number of rows. Keep all rows. The files to be merged have different name and number of rows. For example, the name and order of meats contained in the table meats.xlsx are different from those contained in the table stock.xlsx. Now we want to merge the information in the two tables, and include all meats to the merged file. In this case, simple concatenation is not enough. We need to associate the two tables. Associate the two tables by name column. Join at F means full join, which will keep all rows after join. Then use the new function to extract the required field information. When extracting name values, be careful not to extract null values. The bold code means to select non-null name values. Different name and number of rows, keep only duplicate rows. We still take the above-mentioned two tables as an example. Now we want to merge them and keep only duplicate rows. That is, after merging, only beef, mutton and chicken that are common to the two tables are retained. Associate the two tables. The join function without option means inner join, which will keep only the rows that are common to both tables after merging. Different name and number of rows, keep rows at the first file. We continue to use the two tables as an example, merge them and keep the rows at the first file. The merged table is as shown in the figure. You can see that the types of meat after merging are the same as those in the first file. The option at 1 represents left join, which will retain only the rows of the first file after join. Note that it is the number 1, not the letter L, so be careful not to write it incorrectly. The join function also supports multi-condition merging. For example, we want to add region information to the meat product data and merge by two conditions region and name, and keep the rows of the first file after merging. Adding the condition fields region and name directly to the parameter of the join function can implement multi-condition merging. 3. Horizontal merge, convert file names to column names. For example, there are 3 Excel files, each of which stores a different type of amount value. Now we need to merge the 3 files, and then convert their names to corresponding column names. For instance, the merged table shows that the apple, bread and pork values of Peter are 6, 29 and 7 respectively. Let's write the code. A1, list all file names in the directory. A2, obtain file names without extension. A3, read files as a table sequence. A4, convert amount fields of the original table sequence to corresponding file names while generating a new table sequence. Please note that this code requires the values and their order of the name column in 3 files to be exactly the same. 4. Horizontal merge, one-to-many, copy data. For example, the types table contains descriptive information about fruits and meats, and the foods table contains price information about various fruit and meat products. One descriptive information corresponds to multiple products. For example, both apple and banana are fruits, and they both correspond to the descriptive information about fruits. Now we want to merge these two tables, and add the descriptive information about the product type after unit price, as shown in the figure. This task can be achieved using full join. First, associate the two tables on the values of type field, where join at F represents full join, then use the new function to create a new table sequence and take the required field values. One-to-many, leave subsequent rows empty. If you want the descriptive information about the product types fruits and meats to appear only once, as shown in the figure, that is, the descriptive information is no longer duplicated, then the align function can be used to achieve this effect. The align in A3 means A1 is aligned to A2 with alignment conditions as type column of A2 and type column of A1. If there are duplicate data in A2, only the first row is aligned. In the previous 2 sections, we focused on how to merge data. In fact, due to different operators, different statistical approaches, etc., there will often be more or less duplicate values in the data to be merged. In this section, we will introduce the issue of deduplication in data merging. 1. Vertical merge and deduplicate, duplicate whole rows. For example, there are 2 Excel tables, each storing part of customer data, and there are duplicates in the 2 tables. As shown in the figure, both tables have the data of Lily and Cindy. Now we are required to merge the 2 tables, and take the data of the whole row as criteria for judging duplication. If the data of the whole row are duplicated, keep only one row of data. Unlike the direct merge in section 1, here we need to use merge operation. The merge function is a merge operation, which means to take name and times as the criteria for judging duplication to merge A1 and A2 in order. At U means to get the union, and only one duplicate data is kept during merging. It is important to note that the merge function is an autorelated merge operation, so the source data must be sorted first. Duplicate row headers, keep the data that firstly appear. When merging Excel files, we may use only the row headers, or one or several key columns as criteria for determining whether data are duplicated. For example, there are two tables, it is required to merge them by using only the name column as criteria for duplication. In Customer 1, the times value of Customer Lily is 11, while in Customer 2, the value is 6. According to the requirements, the value of Lily should be 11 after merge. We can also use merge at U to implement this operation, just change the criteria to name. Don't forget to sort the source data by name column first. Duplicate row headers, keep non-null data. In Customer 3 and Customer 4, only one of duplicate data in name column has a quantity value, and the other has a null value. For example, there are duplicate Cindy and Lily in name column, one duplicate data has a value and the other has a null value. It is required to remove the row whose quantity value is null when merging. In this example, duplicate name data correspond to only one quantity value, so we can first filter out the rows whose quantity value is not null from the two tables, and then directly use the concatenation operator vertical bar to perform merge. Duplicate row headers, keep only one non-null data. We still use this example with slightly more complex data. In duplicate name data, there may also be two identical rows in addition to null value. It is required to keep only one non-null row for duplicate name data. For example, both tables contain Peter, it is required to keep only one Peter data after merge. Both tables contain Lily, it is required to keep the non-null Lily data. We can use the group function based on A3 to perform grouping and deduplicating. @1 means taking the first record of the grouping result. Duplicate row headers, delete all duplicate data. Take name column as key column. If the data in the key column is the same, it is considered as duplicate data. It is required to delete the duplicate data appeared in customer.xlsx from customertotal.xlsx. The deduplication result is shown in the figure on the right. It can be seen that Alice, Lily, Peter, and Mark that appeared repeatedly in customer.xlsx have all been deleted. This calculation can be implemented using merge function. @D option means to delete the data that appear in subsequent table from A1. 2. Horizontal merge and deduplicate, duplicate column names, keep data in columns that appear later. The name columns of the two tables are exactly the same. Now we need to merge the information of the two tables, and keep the data of the second file for the columns with duplicate name. For example, both tables contain bread column, it is required to remove the bread data of the first file and keep the bread data of the second file. Since the values and order of the name column of the two files are exactly the same, we can create a new table sequence in A3 and take the corresponding column values from the two tables. 3. Vertical and horizontal merge simultaneously, keep data that firstly appear. For example, the name columns of the two tables are different, but the two columns have duplicate data. And both tables have bread values. It is required to merge these two tables. For duplicate data, it is required to keep the one that firstly appears in customerfruits1.xlsx. For example, the bread value of Lily in the first table is 144, and the bread value of Lily in the second table is 120. After merging, the value in the first table should be kept, so the bread value of Lily in the merged table is 144. First, transpose the original data of pivot structure to a list. Merge the two lists and use the group function to group and deduplicate. @1 indicates taking the row that firstly appears after grouping. After deduplicating, transpose the data back to pivot structure table. Pivot means the operation of converting rows to columns, and pivot at R means the operation of converting columns to rows. Aggregate files. It is also a common requirement to aggregate data while merging multiple Excel files, such as monthly or annual aggregation. This section will focus on the aggregation of files. 1. Same rows and columns. As shown in the figure, each file has the same column's name and amount, and the values in the name column are in the exact same order. Now, it is required to aggregate the values of amount column to form a total amount column and save it in a new file. Because these three files have the same rows and columns, we use the new function to create a new table, and then directly take out the values of the amount field from the three tables and add them together. 2. Different rows and columns. If the values and order of the rows to be aggregated are not the same, they cannot be added directly. For example, there are two tables, which respectively stores the monthly sales data of some products in 2023. Now we need to aggregate the sales value of each product, and the result is shown in the figure on the right. Since the data of product column of the two tables are different, they cannot be added directly. The code can be written this way, but the files to be aggregated in the same path, such as the test folder on drive D. Use the directory function to return the directory of all .xlsx files in the test folder. Loop through the files in the path and merge them together using the conjunction function. Then use the groups function to group and aggregate by product and sum the sales of each product. 3. Vertical and horizontal merge simultaneously, aggregate duplicate records. Let's take the data used in group and deduplicate as an example. Both tables have name columns, but the values are different and there are duplicates, and both tables have bread values. It is required to merge the two tables and aggregate duplicate records. For example, the bread value of Lily in the first table is 144, and the bread value of Lily in the second table is 120. After merging and aggregating, the bread value of Lily in the merged table is 264. First, use pivot_r to transpose the original data of pivot structure to a list, and then merge the two lists and group and aggregate by name and column. After aggregating, transpose the data back to pivot structure. 4. Aggregate by cell positions and fixed number of files. The head office has received the balance sheets from every branch, of which the table of a certain branch is shown in the figure. There are 37 rows in total, but only 14 of them are shown in the figure. Now we need to aggregate the balance sheets of every branch to generate the balance sheet of head office. In this example, it needs to read the values of corresponding cells in multiple files for aggregation. Now let's write the script. A1. List all the to-be aggregated balance sheets whose file names begin with ZC in the folder, and at P option means to list the full path of the file. A2. Open the files listed in A1 as Excel objects. A3. Specify the round number range of to-be aggregated numeric cells, which is 4 to 37. B3. Specify the column numbers of to-be aggregated numeric cells, which are B, C, E, and F. C3. Spell out the names of all to-be aggregated numeric cells using the round numbers in A3 and column numbers in B3. A4. Loop through all to-be aggregated numeric cells in C3. B4. Define the aggregation variable V. B5. Loop through balance sheets of all branches. C5. Read the value of current aggregation cell from the balance sheet of current branch, convert it to a number and add it to V. B6. Save the added V to the balance sheet of the first branch. A7. Save the balance sheet of the first branch to the balance sheet of head office total.xlsx. 5. Append an aggregate. There is a daily purchase and delivery table of goods and a daily purchase, delivery and inventory summary table of goods. Now we want to append the daily purchase and delivery data to the summary table in order to calculate the latest inventory. The latest inventory is equal to the inventory of the previous day plus purchase minus delivery. For example, the inventory of milk on August 3, 2020 is equal to the inventory 59 on August 2nd, plus the purchase 18 on August 3rd, minus the delivery 12 on August 3rd. The result is 65. A1. Read the data of current day and add a new column inventory. A2. Read the data of summary table. A3. Loop through every row in A1 so that the value of inventory is the inventory of the last goods in summary table plus the current purchase and minus the current delivery. At Z1 option means to select the first row that satisfies the condition from back to front. A4. Append and save the result of A3 to total.xlsx, and at A option means to append data. 6. Cumulate and aggregate. There are daily sales tables of some goods in current month, with one file for one day. Now we need to add cumulate values to the monthly cumulative sales columns of these files. As shown in the figure, today's monthly cumulative sales is equal to yesterday's cumulative sales plus today's sales. Now let's write the script. A1 and B1, list the date range to be counted, such as the 1st of January 2022 to January 31st. A2, generate all file names to be calculated in chronological order. A3, loop through all statistical tables in A2. A4, define the cumulative value of the first day as the sales of that day. A5, start the loop from the statistical table on the second day. B5, loop through every record in the current statistical table so that the monthly cumulative sales on the current day is equal to the sales on the current day, plus the monthly cumulative sales of the goods on the previous day. A6, loop through all calculated statistical tables in A3 and save them to the file names with the corresponding sequence numbers in A2. 7. Insert aggregation sheet. For example, the sales details of each product are stored in multiple sheets of the same Excel file. Now we need to generate a summary sheet in the Excel file to obtain the total sales of each product. A1, enter the sheets to be aggregated, such as sheets 1 to 12, which represent the sales data for 12 months. A2, loop through sheets 1 to 12 and merge them into one table. A3, group and aggregate by product to get the total sales of each product. A4, write the total sales to the sheet named Total. The option OK means replacing the sheet in the original file. If there is a sheet named Total in the original file, replace the content inside the sheet, otherwise, a sheet named Total will be generated. AT means the first row is the header. Format conversion. Sometimes we will also encounter the situation of converting some special format tables, such as card style table and primary subtable. Let's look at some examples. 1. Merge multiple card style files into a row-based table. There are multiple card style files. Each card contains basic information of an employee, such as ID, name, title, birthday. It is required to merge these files into a row-based table, and the merged table is like this. By observing the data, it can be seen that the cell containing the same information is in the same position on each card. For example, the ID values are all in cell B2, and the title values are all in cell B3. So, similar to aggregating by cell positions, we need to read the values of these fixed position cells and then write them into a row-based table. Let's write the script. A1, list all files named after a person's name in the cards directory. A2, create a result table sequence with the field name being the information to be extracted from the card. A3, list the cell names in the card style files to be read. A4 to B6, loop through the files in A1, read the data of cells listed in A3 and write them into the table sequence created in A2. When reading the content of a cell, it needs to use XLS open and XLS cell. A7, write the table sequence in A2 to employee.xlsx. 2. Merge multiple primary subtables into two row-based tables. There are multiple primary subtables, each of which contains basic order information and detailed order information. For example, the first 4 rows in the first table is a primary table, containing information such as order ID and order date. Starting from the 6th row is a subtable, listing the product ordering details for that order. Now we need to separate the primary table from each file to form a row-based table named orders, and separate the subtable from each file to form a row-based table named order details. In this example, the primary table is a card-style table, and the subtable is a row-based table. We will handle them separately. The subtable is a row-based table and can be read directly by row. The primary table is a card-style table, similar to the previous example. It also needs to read the values of certain cell positions. Let's look at the script. A1, list the .xlsx files starting with order in the orders directory and open them one by one. A2 and A3, create a table sequence for primary tables and a table sequence for subtables respectively. A4, loop through the files in A1 one by one. B4, read the data starting from the 6th row in the file, return a table sequence, and add an order ID column. B5, read the data of the primary tables in the file one by one and insert them into A2. B6, insert the subtable data read from B4 into A3. A7, write the table sequence for primary tables in A2 to the file orders.xlsx. A8, write the table sequence for subtables in A3 to the file order details.xlsx.